I have exactly the same situation. Again, what I'm plotting here on the vertical axis, I have the pressure inside my barrel, and that's represented by this curve right here. And in this particular graph, I'm plotting, instead of plotting position, I'm plotting time. So it's how long it takes for a stroke. So the distance between this point and here, if I'm going at 10 strokes per minute, it takes 6 seconds to go from here to here. That's 6 seconds of time during the upstroke. So the upstroke is roughly 3 seconds and downstroke 3 seconds. And what I'm plotting here is what happens to the pressure inside when I have a mixture of gas, these are trying to represent gas bubbles, and liquid coming into the pump. So the plunger moves back, the pressure drops, and when it drops below this level, which is the pump intake pressure, the valve opens and I start admitting a mixture of fluid. And the mixture of fluid is a mixture of gas and liquid. At the top of the stroke, I will have, and by the way, if you look at this through a clear plexiglass pump, one of the things that occurs or shows up is that segregation of the fluids is quite rapid. By the time, in 3 seconds, you get most of the gas at the top of the barrel and most of the liquid down here. And so at the top of the stroke, if you were to look at it, you will have separation. The gas is here. On the downstroke, the plunger moves down, but since this is a compressible fluid, the pressure takes some time to build up, and it builds up according to that hyperbolic shape. At this point here, the valve opens, and then I will have the gas flowing through, and then I will have the liquid coming through. Now, this particular series of pictures, and you have the actual PDF files in color, so when you look at this on the CD, you will be able to follow, are from a series of videos that we took. We have a full-size clear pump and well, and you can download these videos if you go to the ALRDC website. ALRDC is the Artificial Lift Research and Development Council. You can download these videos. And what we're looking at here are several things. So on this side we have a picture. This is the traveling valve. It's a clear plexiglass traveling valve. Here is the ball seated on the valve. We are at the top of the stroke at this point. So this diagram here shows where we are. The stroke of this pump is 24 inches, roughly 2 feet. So we are at 23.7 inches. That's at the top of the stroke. The pump is partially filled with liquid and gas. Here we have 4 curves. The sinusoidal curve here is the position of the plunger. So you see we are at the top of the stroke. Here's the bottom of the stroke. The vertical line indicates where we are now. That corresponds to this picture. This line here represents the discharge pressure. The blue line represents the pressure inside the barrel, or the pressure here, and the red line is the pressure below, the intake pressure. Now we're only looking at the downstroke here to see what's happening on the downstroke. So I'm going to move to the next position, and you will see that the vertical line here has moved from this point to this point, indicating that the plunger has moved down. How far does it move down? Well, it was at 23 inches, now it's at 15.7 inches, so we have moved down quite a distance. The pressure has built up from this value to that value, but that value is still below the pressure at the discharge, which is the pressure above the ball, so the ball is still closed. And by the way, here is the ALRDC.com. That is the website where you can go, and on the right-hand side you will have a link to videos and animations, and I strongly recommend that you go there, and there are a lot of interesting things there. Okay, so we are at 15 inches. We've compressed the gas. The gas pressure has built up to about twice what it was. Now we move further down, and now we're at 11 inches, and you see that now where pressure has built here, but it's still below the green line. We haven't quite reached the point where the valve is going to open. And we move down a little bit more, 10.8 inches, and still the ball is seated over here. You see that there is no gas. And we move down a little bit more, and if you're careful here, you see those gas bubbles over here start showing up at that point. Okay? And then when I move to that point, now you see a lot of gas that is coming through. So here is the plunger, and you see now that we have gas coming through the plunger as the plunger is sliding through the fluid. So this is what we call gas interference, as opposed to the fluid pound case, where you really have to get to the liquid interface, gas-liquid interface, to open that valve. Okay. Okay. Now from that point on, the pressure remains constant over here, and all we're doing, we're discharging more gas, and eventually we discharge any liquid. So that's the cycle on the downhole. Now, how do we recognize this? How do we visualize this by looking at the dynamometer card? And so what I have here is the example, the same example that we have here. And again, we're looking at this portion of the card, the downstroke. That's when the pump is pumping. It's pumping on the downstroke. That's when fluid is being transferred from the barrel to the tubing. And so we start out with gas at point A and liquid. And again, the segregation is quite rapid, so this is a very realistic situation. And then as the plunger moves down, it compresses the gas. When the gas pressure exceeds the pressure above, at 5,000 feet, we have to go from whatever pressure we have to 2,500 psi roughly. So the pump is a pretty good gas compressor, and when it compresses the gas, the valve opens, and now the fluid is transferred, from and the fluid meaning the combination of gas and liquid that we have. Now Lynn